So now we'd like to convert decimal to floating point, now that we know how to convert floating point to decimal. So basically we start out with the data here, or that we want to, well, this is the date what we're trying to come up with, and we want to start out with a number and come up with that way of encoding it. So we're trying to convert a decimal number to IEEE 754 floating point. So first step is to convert the absolute value of the decimal number to a binary integer plus a binary fraction. Then we need to normalize the number in binary, and we use binary scientific notation to obtain the exponent. We bias the exponent by 127, set s equals 0 for positive number, s equals 1 for a negative number, and we combine the results and put them all together. So here's an example. We want to convert 22.625 to floating point. So first of all, we convert that 22 to binary, and that's given right there, 10110. Can do that by the division process we talked about, or notice that it's 16 plus 6. So next thing, we convert the 0.625 to binary, and the 0.625 is 0.5 plus 0.125, which is 0.101. And there it is, 0.101. So now we combine the integer and the fraction, and we now have 10110.101 times 2 to the 0. Now we need to move the decimal place over 1, 2, 3, 4 places. So that's normalizing it. So it's 1.011001 times 2 to the 4th. So then we need to figure out the exponent is 4. So we have to bias the exponent, drop the leading bit. That's the leading on the 1 point. You drop the 1 on the 1 point there, and figure out what the fraction is. And the fraction will be 0 or 0.0, or well, the fractional part will be 0.10101, and so we end up with the biased exponent. We have to add 127 to that, so it's 1.0000011. And the sign it's positive, so we put a 0 in front. So the sign is right here, the exponent is right here, and then this is the fractional part of the number. So there you have it, an IEEE floating point. So here's a quiz for you. See if you can do this minus 25.8125. And then you might want to try this minus 37.375.